All right, what's going on, guys? How are we doing? It's Coach Haas, and today we are going to be talking about division. So, a lot of what we have been talking about lately has been operations with polynomials. So, we know how to add, subtract, multiply, but we don't know how to divide yet, right? Now, before we can start talking about division of polynomials, let's refresh on what we know about long division. I know everybody hates it. So, there are two types of division with polynomials. Two types of division. Number one, long division. And then number two, synthetic. Now, the main one I personally like to use is long division, but the one that's easier to use in the future, whenever we get into huge equations, is going to be synthetic. We're going to be using synthetic division quite a bit over the next couple days. Now, for that reason, since I cannot be there today, we're not going to talk about synthetic division yet. I might introduce the idea, but today, our main focus will be long division. So, what is long division? Long division is that thing when we have like 25 divided by 5. We take the 25 and put it under the little house thingy, divide by 5, and then we go based on place value. So here we pretend like the 5 doesn't exist, and we would find some number times 5 to get 2. Now the catch is we want to stay positive. So what number times 5 equals 2? Well, no number does, because 5 times 2, or sorry, 5 times 1 is 5, and 5 is greater than 2. Therefore, we cannot do it. So, what do we do in this situation when we cannot do some operation? We put 0. And then we no longer pretend like this doesn't exist. We then do 5 times what number equals 25? Well, 5 times 5 is 25. We know that for a fact. So we put it up here. Subtract 25, and we get 0. Now, this is called our quotient. This is called our remainder. So why does this matter? Well, whenever we're adding polynomials, if we have like x plus 5 plus 3 plus 4x, right? We've been taught to rewrite this as 4x plus 3 and then add these together. That gives us 5x plus 8, right? So what happens if we have x plus 5 minus x plus 3? Well, we're taught to take this and change all of the signs in this equation, right? So, and then we add them together. So this becomes minus x minus 3. That gives us 0 plus 2. Therefore, our answer would just be 2. Then from there, we were taught to multiply polynomials. So if I have x plus, or sorry, so if I have x times x squared minus 3, this distributes into everything. And that gives me x cubed minus 3x. Right? So this is all just review of stuff that we've already been doing. Now, all three of these things play a huge factor into what we're about to get into. So, what about division? When we divide, what we do is, you know, we have like some number like 74 divided by 3, right? If we want to do long division, what we do is we take 74, put it here, and divide it by 3. So 3 times what number is close to 7? Well, 3 times 2 is 6. 3 times 3 is 9. Well, 9, that's too big. So the closest number that we can multiply by is 2. So we put a 2 here. 2 times 3 is 6. And then I subtract these. Nothing on the 4, so the 4 just comes down. 7 minus 6 is 1. So now I'm left with 14, right? And then if I wanted to, I could just do this, divide by 3 again. So 3 times what number is 14? And by equals, I mean is close to. Well, 3 times 5 is 15. But 15, that's a terrible 5, is greater than 14. Therefore, I cannot use 15. Or I cannot use 5. But 3 times 4 is 12. 12 is less than 14. Therefore, I can use it. So let's multiply by 4 here. So that gives me 12. Then I subtract them. This is going to give me 0. This is going to give me 2. Now, I could continue, but I don't want to do decimals for this. So here's my quotient. Here's my remainder. So we would write this as 24 plus 2/3, because this is 2 divided by 3, right? There's my answer. Now, how does this work for polynomials? That is the question of the hour. So, polynomial long division. All I'm going to do is I'm going to take what I know about long division, which I'm now going to abbreviate by LD. I'm going to take my knowledge of long division and apply it to polynomials. Well, for polynomials, I know how to add, subtract, and multiply, which is everything that we need for long division. So let's say I have x squared minus 3x minus 40 divided by x minus 5. And I'm using these numbers specifically for a reason, which you'll see. If I chose my numbers right and if I do my math right, we should, it should come out cleanly. So if I have 1 divided by 3, that's just 1/3. If I have 2 divided by 6, that's 2/6, which we could also reduce. Again, now that doesn't really matter, but the whole point is if I see something written like this, I can write it like this. So let's do exactly that with our polynomial. So this becomes my numerator. This becomes my denominator. Numerator is just the top. Denominator is just the bottom. So let's do it. X squared minus 3x minus 40 divided by x minus 5. Well, I know I can write this as x squared minus 3x minus 40 divided by x minus 5. So remember, one of the key things that we're going to have to do here is we have to find some number here times everything here to cancel this stuff here. Now, remember, I am multiplying here. And whenever I multiply something, I have to do it by everything here, which I'm going to write all of that out for us. So, without further ado, let's begin. So pretend like the 5 isn't here for a minute. If I just have x times what number gives me x squared? Well, we know based on the definition of exponents, x times x equals x squared. So I start by multiplying by x. Now, remember, I have to take this number and multiply it by everything here, not just by x and not just by -5. So, oops, I have x times x minus 5. Well, this is going to distribute here, and this is going to distribute here. That gives me x squared minus 5x, right? So now I take this and I plug it in over here. So that's x squared minus 5x. Now remember, I have to subtract this. Now, whenever I'm subtracting things, I have to flip all of the signs. Okay, so just so this comes up cleanly, I'm going to change this to plus 3x. Forgive me, but I'm changing this symbol to plus 3x so it comes out clean. So after I flip all of my signs, I'm combining like terms. So here's a negative, here's a positive. These cancel. 5x plus 3x, that's 8x. There's nothing on the 40, so it just comes down. Now, again, let's just think like the 5 isn't here for a minute. X times what number equals 8x? Well, 8 times x equals 8x. So let's add 8 here. So now I have 8 times x minus 5. This is going to distribute everywhere. That's going to be 8x minus 40. Well, as we notice, that's exactly what we get here. Now remember, I have to subtract this. I subtract my product from what I'm going by. Now, whenever I subtract, I change the operation and I change all the signs. These are going to cancel, leaving 0. These are going to cancel, leaving 0. Therefore, my quotient is this, and my remainder is this. So now we have x plus 8 plus a 0 remainder, or we could just have x plus 8. So that's going to be my answer. And that's polynomial long division in a nutshell. So, so let's take all of this, get rid of it. Then let's do this one. So I can first rewrite it as x squared plus 7x minus 30 divided by x minus 3. Now, what do I do next? I rewrite it in long division form. X squared plus 7x minus 30. And if you think you could go straight from this to this, go on ahead. I just like visualizing it like this first. That way I can easily write it like this. So then the x minus 3 goes right here on the outside. So we'll get rid of this. We'll get rid of this. And we'll begin. So remember, I'm multiplying right here. So let's pretend like the 3 does not exist right now. X times what number is x squared? Well, x times x is x squared. So I put that here. X times x minus 3. This distributes. That gives me x squared minus 3x. So I put x squared minus 3x here. And remember, I am subtracting this. That means I flip all the signs, change my operation, and combine like terms. Well, these cancel, leaving 0 plus 7 plus 3. That's just 10x. There's nothing attached to the 30, negative 30, so it just comes down. Now, x times what equals 10x? Well, x times 10 equals 10x. So I take this number right here, put it up here. So 10 times x minus 30, or sorry, getting ahead of myself. 10 times x minus 3, that's 10x minus 30. So then I take this, plug it in right here, and then I subtract them. Whenever I'm subtracting, I change all of my signs and then combine like terms. These are going to cancel, leaving 0. These are going to cancel, leaving 0. So here's my quotient. Here's my remainder. I now have x plus 10. Okay, let's do one more example. So we'll get rid of all of this. Oops. And then we'll do this. So I'm just going to go straight to the point. This goes under x squared minus 13x plus 12 divided by x minus 1. So we know that x times x is x squared. So x times x minus 1, that's x squared minus x. So x squared minus x. I'm subtracting these, which means I change all of the symbols and then combine like terms. These are going to cancel, leaving me with 0. 13 plus x, that gives me negative 12x. There's nothing on the 12. So we just bring it down. Now I have to get rid of all of this. So x times what equals negative 12? Well, negative 12 times x equals negative 12x. So negative 12 times x minus 1, that's going to be this. Negative 12x plus 12. Okay. So I can take this minus 12, because remember, that's what I'm multiplying by. Negative 12x plus 12. And remember, I am subtracting these. So change all of the signs. This becomes minus. These are going to cancel, leaving me with 0. These are going to cancel, leaving me with 0. Here's my quotient. Here's my remainder. Therefore, my answer is going to be x minus 12. Okay. Hopefully this helps you guys get started on our, oops, what is going on here? Hopefully this guys helps y'all with what we are doing. If you have any questions, please feel free to email me. Um, and yeah, I think that's going to be everything. You guys have a good night and good luck on the rest of y'all's assignments for this day. Bye.